Engineers today are tasked with deploying AI agents directly into cloud environments like AWS Lambda. AWS Lambda is a serverless computing service that runs code in response to events without requiring you to provision physical servers. Curious, but an isolated AI agent is limited. Looking at this architecture diagram, the central node provides no value until it is authorized to connect to external systems, like a database, an LLM, or a SaaS application. Most developers focus on the AI's logic rather than identity security. To get applications running quickly, they rely on familiar methods to establish connections. This creates standing privilege. Workloads receive hard-coded, static API keys, unique codes to authenticate a program, keeping connection lines to external destinations active indefinitely. Prioritizing this ease of setup over strict identity controls turns a helpful AI agent into a potential entry point for unauthorized access. Faster, more urgent tone. This entry point is exposed during a prompt injection attack. Prompt injection is a technique where a user provides specifically formatted text to trick an AI into ignoring its original safety instructions. The risk isn't just the AI's output. The attacker actually hijacks the agent's identity. The hacker commandeers those hard-coded static credentials. With those credentials, the attacker moves past the AI's interface to gain direct read and write access to the company's entire database. The AI effectively becomes a blind conduit, allowing a remote attacker to query or delete sensitive data using the agent's own permissions. Securing autonomous AI requires moving away from static, permanent passwords for these connections. This shift is defined as Agentic Security Runtime. The process begins by removing standing privileges entirely. Instead of holding a permanent password, the AI agent receives a temporary credential generated only for a specific data request. These session-bound credentials are valid for just seconds or minutes and automatically revoked the moment the transaction completes. If a credential is intercepted during a prompt injection, it becomes useless almost immediately. This architecture limits how much data an attacker can access, even if they bypass the AI's initial guardrails. While the agent executes code, it typically operates via HTTP interfaces on behalf of a human user. HTTP is the standard protocol used for sending data between a web browser and a server. To maintain security, the AI must verify exactly who is making the request before executing external actions. This verification is handled by an identity provider, or IDP, using the OAuth 2.0 authorization code flow. An IDP is a system that creates, maintains, and manages digital identity information. You likely use this standard daily when you see a log on with Google or log on with Microsoft redirect page. By linking the AI's actions to a verified human session, the agent is prevented from initiating tasks without a valid, authenticated user context. Some actions require even more scrutiny. For example, if an internal HR agent is asked to formally offboard an employee. Relying on a simple browser-based login is insufficient for operations that carry significant financial or personnel risks. This is OAuth 2.0 CIBA, or Client-Initiated Backchannel Authentication. It separates the computer request from the device approval. Acting as secondary verification, the AI agent prompts the user's smartphone to request explicit approval for the sensitive action. In the event of a prompt injection, where malware tells the AI to offboard all employees, the user would see a notification for every single unauthorized request on their phone. CIBA introduces a physical verification step, ensuring that prompt engineering alone cannot trigger high-risk actions without manual approval on the user's mobile device. These security protocols are integrated directly into the AI agent's Python or TypeScript source code. This diagram shows the internal runtime loop. The agent's code evaluates JWTs, JSON Web Tokens, which are compact, URL-safe means of representing claims to be transferred between two parties. It then requests the dynamic credential, executes the action, and triggers revocation. This creates a runtime environment that treats the prompt as untrusted until the identity and session are verified. By combining session-bound credentials with out-of-band verification, organizations can move AI agents into production with a governed security framework. Understanding these identity standards is the first step towards building secure, autonomous applications. To see how to implement these patterns in your own code, subscribe to Learn by Doing with Steven YouTube channel for technical deep dives. For more on AI trends and engineering best practices, listen to the Stephen Data Talk podcast on YouTube Music and Spotify. Check the links in the description, and thanks for watching.